Good morning, everyone, and welcome to SciFest 2025. This is day 2 of our events, and we're very excited to be joined today by Grant from the Australian Age of Dinosaurs, who will be reading his story, Deep Time Astronomy. So we're very excited to have him here with us today and to have everyone here joining. We will be using the chat if we have a question that Grant asks you. It may come up through the session that he might want to know a question from you. But if you've got a question to ask Grant, please put it in the Q&A for us. So Q&A, if you've got a question for us, we've got one in there already. Oh, we've got Samuel. Hello. So for those kinds of things, you can put them in the chat. And if you have a question that we'll get to at the end of the session, you can put that into the Q&A. So Grant, I'm going to spotlight you because you are the most important person. You and your dinosaurs are the most important person in our session
Morning, everyone.
today. So I'm going to hand over to you, and I'm looking forward to hearing your science story as well. Thanks, everyone.
Wonderful. Thanks, Karen. And yeah, welcome, everybody. So my name is Grant. I'm here at the Australian Age of Dinosaurs Museum. And today we're going to read this little book, The Wonderful Story of Deep Time Astronomy. So we're going to have a look at the close-up camera, and you can read along with me here. So this one was, written by myself, but illustrated by the wonderful Jennifer Horn, who's written and drawn all these wonderful little illustrations, all these cute dinosaurs here to go with our Deep Time Astronomy book. So let's get started. First, what is astronomy? Astronomy is all about exploring things that are far away from Earth. This includes the moon, planets, sun, stars, and galaxies. People have been studying astronomy for a really, really long time. Early astronomers passed down stories and knowledge of super bright star explosions in the sky and comets that came by regularly. Astronomy has helped people to navigate when traveling, record important information, and know when to harvest their crops. The first thing we learn about is the Big Bang. About 14 billion years ago, the whole universe was inside a tiny bubble that was even smaller than a pinhead. It was super hot and packed with stuff, way more than we can even imagine. Then something incredible happened. It was a gigantic explosion called the Big Bang. This explosion was so powerful that it pushed everything away from everything else. In less than the blink of an eye, the universe went from being the size of a teeny tiny atom to becoming bigger than a whole galaxy. And guess what? The universe is still getting bigger and bigger every day. So did you know, after the Big Bang, it took about 9.5 billion years until our solar system, that's our sun and planet Earth, were formed. That's a very long time. So how did the universe form? Well, the universe came into existence after the Big Bang. But scientists don't know what caused it, or even if there was a cause. But right after the Big Bang, the very first and lightest element, called hydrogen, appeared. Now, places with more hydrogen had a little bit stronger gravitational pull. And in those places, more and more matter came closer together. And that's how big stars and galaxies begin to form. It all starts with gravity. Now, if you want to imagine space, what is space really like? Of course, there's large areas with nothing, but if you think of space here like a piece of Swiss cheese, and there's the cheesy bits, and there's the holes in the middle. Now, everywhere that we've got cheese, you could think of that as being the matter and the galaxies, the stars, all of these gases. But the holes that are scattered throughout the piece of cheese, that empty space, that's where there aren't many stars or gases or even planets. Our next job is to understand time and distance, because the universe is absolutely huge. Astronomers use light rays to figure out how far apart things are in space. Light is really fast, so it helps them measure the gigantic distances in the universe. Now, if we look here, imagine the universe is so big that if you were trying to measure the distance to the sun from Earth using kilometers, it would be a bit like trying to count how many bananas it takes to put end to end to measure the distances between, say, Brisbane and Sydney, or your nearest capital city. It really is not practical. So it's much easier for astronomers to use light. This brings us to something called the light year. So imagine if light was a really super fast rocket. Light zooms through space at a whopping 300,000 kilometers every second. To put this in perspective, it only takes 1 second for light to travel here on Earth up to the moon. The journey to Earth's closest neighbor star, called Proxima Centauri, is so far that it takes light more than 4 years to get there. That really is a very long way away. But now imagine if you could travel at the speed of light yourself. Just imagine for a minute. If you were traveling that fast, you could run around the Earth's equator 7.5 times in just 1 second. That's an incredible distance to cover in just 1 second, and that's how fast light goes. So now we're about to set off on an adventure into deep time. And we're going to have a look at some of these geological time periods as we step forwards on this adventure. So these act as markers. So for example, the early Earth forms around 4.5 billion years ago. And lots of things happen here before we get any significant life. But let's step forwards, because eventually we're going to arrive at the Mesozoic, or the Age of Dinosaurs, from 252 million years ago until 66 million years ago. Let's set off. So the Precambrian. So the Earth formed 4.6 billion years ago. It was basically a giant ball of super hot molten lava. So you can imagine volcanoes here spewing out molten rock. The Earth is so hot that life simply can't live on it at the moment. But a little bit later, around 3.5 billion years ago, the first signs of life emerged in what would become Western Australia. And these rock-like structures are called stromatolites. Now, these little mounds of rock that we can see illustrated here, basically they form because these cells of bacteria, they grow underwater, and very slowly old cells die, new cells grow on top, and layer by layer, these columns appear to grow up from the seafloor, and those are called stromatolites. The oldest evidence of life on Earth is found in Western Australia. Then we step forwards to the Paleozoic, around 500 million years ago. Shortly before the star Vega formed and began to twinkle in the night sky, an exciting event unfolded on Earth. A grand parade of diverse creatures began inhabiting the water and land in an event called the Cambrian explosion. Now, this is not a regular explosion, but it's literally all this life appearing very, very rapidly in the fossil record. But did you know there was a really terrible climate event around 252 million years ago, and it caused worldwide extinctions of all creatures and plants? About 95% of all life on Earth was wiped out and had to start again. "252 million years ago, we arrive here at the Mesozoic. And during the Mesozoic era, which is the age of dinosaurs, the brightest star in the night sky, Sirius, began making light. There were two new continents called Laurasia and Gondwana, formed as the supercontinent called Pangaea split up. It literally split into two, and Gondwana stayed down here in the southern hemisphere. Laurasia started to move further north. The age of dinosaurs ended 66 million years ago when an asteroid impact caused dust to block out the sunlight. This event caused the extinction of many animals, including dinosaurs, all around the world. Then we arrive at the Cenozoic. After that dinosaur extinction event 66 million years ago, all the way up to the present day. Some early small mammals survived that dinosaur extinction event, beginning a new era. And around 16 million years ago, a beautiful cluster of stars called the Jewel Box cluster sparkled above in the sky. And it looks a little bit something like this. It makes like an arrowhead or a triangular shape of these bright stars. Now, our early megafauna here in Australia, they could see some of these stars appear in their sky, which is really incredible, about 16 million years ago. Let's have a look now at some different types of deep sky objects. There are galaxies, nebulae, planets, and star clusters. We'll explain a little bit about each of these. Galaxies are the biggest. They are filled with billions of stars, nebulae, star clusters, gas and dust, and come in different shapes. Some have a flat spiral shape, just like our Milky Way does, looking in this spiral pattern. Others are rounder and football-shaped and called elliptical galaxies. Now, did you know at the very center of almost every galaxy, there is a massive black hole? You can imagine it's a little bit like a super strong vacuum cleaner, but no need to worry because it can't pull everything in. What it does is keep everything, all these stars, orbiting around the center. Without it, we wouldn't be able to have the structure of our Milky Way galaxy. So Earth is safe. We're not going to get sucked into this black hole. If we have a look at nebulae, nebulae is the plural. When you count more than one nebula, you've got two nebulae. So a nebula is a cosmic cloud made up of gases and dust floating in space. It's a special place where stars are born. And in the southern hemisphere, we can see one of these, the Carina Nebula. We can also see the Lagoon and Tarantula nebulae as well. So inside a nebula, there are dense clouds of hydrogen gas. And these clouds clump together, get squished by gravity. As they squeeze tighter and tighter, they become hot and start to glow. And that's when a new star is born, like this little baby star here. So they are literally called stellar nurseries. Now, planets are much more familiar. I'm sure you've seen many of these in the sky. Planets are large objects that orbit a star. They are small and rocky, like Earth, or can be large and gaseous, like Jupiter. When a star is born, there's a lot of gas and dust swirling around it. Over time, some of that stuff starts to stick together and form clumps. These clumps grow bigger and bigger, eventually becoming a planet. There are two types of star clusters. There are super compact globular clusters. Imagine it's like a city. Bustling cities filled with hundreds and thousands of stars all clumped together. They're so close together that they can't help but be pulled toward each other by their own gravity. And then there are open clusters. They have a few stars, more like smaller groups of stars sitting around a campfire. These star gatherings are not as tightly packed together, so they have more space to spread out. And over time, these star clusters start to drift apart because there isn't enough mass to hold them together. Now, you might recognize this little group of stars right here, this open cluster, that arrowhead or triangular shape. That was our star cluster we met earlier, the jewel box cluster. There are a lot of constellations in the Southern Hemisphere. We're going to point a couple of them out. So in the Southern Hemisphere, there are some really cool constellations that we can easily see in the night sky. They have special names like Orion, Taurus, Carina, Scorpius, Gemini, Canis Major, and Crux, which is also known as the Southern Cross. All constellations or arrangements are areas where shapes can be seen, which makes it easier for people to locate them. Now, if you look at this little pattern here, can you see the shape of an emu? This celestial arrangement is known as the emu in the sky, and it extends across the entire night sky, formed by the darker regions in the Milky Way. So if you imagine for a moment, just up here is the head of the emu, and as we stretch down following its neck, the curve of its top of its back of the emu out here, all the way down to its tail feathers and back up under its body to its neck and head again. At the moment, in winter is the perfect time to see the emu in the sky. That is literally our entire or half of our Milky Way galaxy making up that shape. It really is amazing to see. So when you get a nice dark sky night one evening, go out and try and spot that emu in the sky. It's directly above you at the moment. I'm going to skip to one of my favorite constellations here. And this one's called Carina. So Carina, it's a keel-shaped constellation which has the Carina Nebula. And that means it's part of what used to be a boat, like a sailing boat, and the keel, or the very bottom of the boat underneath the water. Now, this Carina Nebula, it started shining about 3 million years ago. The star Eta Carina sits right in the middle of the nebula, and scientists think it may explode soon. So that Carina Nebula is very easy to spot. It's just to the right of the Southern Cross. And I'll show you where the Southern Cross is. We'll skip ahead here to Crux, or the Southern Cross. I'm sure we've all seen this one, and we know where to find it on our flag as well. So the Crux is a very tiny constellation that appears on the Australian flag. Inside this constellation is the Coal Sack Nebula, and that nebula is filled with dust and gases that block the light from behind it, making it look like a dark cloud. So here's the Southern Cross. We've got the top, the bottom star and the left and right arms of the cross there. And that little fifth star that we also see on our flag. Now that Coal Sack Nebula that we just mentioned, it sits right about here. See this dark region just there. And that is the head of the emu. So when you're out looking for that emu in the sky, look up, directly up at the moment, find that Southern Cross just nestled against the left-hand edge of the cross there. That is the head of the emu, and its body stretches down towards the pointers and off into the rest of the Milky Way galaxy. All right, so let's have a quick look about how to stargaze, because it really is good fun. So when it gets dark, outside, go to a quiet and dark spot in your backyard where no lights will bother your eyes. Lie down for a while, give your eyes some time to get used to the darkness. You might want to put on a warm blanket too. But once you feel ready, look up at the sky. It really is as easy as that. And I'm sure you've learnt how to find south as well. Because whenever you can see the Southern Cross, we imagine drawing a straight line from the top to the bottom and keep extending it outwards. And then we go to the pointers just here. Halfway between them, we draw another right angle line and extend that outwards in the same direction. And where those two lines appear to meet in the sky, that is called celestial south, which is the same direction as true south, the true south pole of planet Earth. So once you know where south is, you can turn yourself into a compass and find north, east, and west. So why are dark skies so important? They're important to human health, plants, animals, and our ability to experience the wonders of a starry night sky. When the sky is really dark at night, we can see objects that are light years away, even without telescopes. And it really is by looking up at this dark sky that allows us to wonder about how everything is connected and how vast the universe is. It can inspire us to become scientists or simply to learn more about the world around us. And here we go, the last image. We've got a little picture of our reception museum building here. And you might even just be able to see Banjo, the Ostler Venator, sitting out the front of our museum building there, looking up at this nice dark sky, seeing all these incredible stars. All right, and that brings us to the end of our little book. I'll just go back to our main screen here. And if anybody does have any questions, as Karen said, Karen will be able to find some of those in our chat, and we'll try and answer as many as we can.
Absolutely. We've got a few that have come through already, so please feel free to put those in as we're going as well. So we have one here from Isabel. Why do scientists think the Carina will explode soon?
Yeah, very good question. So it turns out with stars, when they get to a particular color, they go, as they get towards the end of their life, they cool down and they become more orange, red stars. They also expand in size and they become larger and larger to what they call a red giant stage. And once stars get there, they're really close to going supernova or reaching the end of their life where suddenly they run out of all their hydrogen fuel and they collapse very quickly. They collapse so quickly that it then causes this explosion called a supernova, the end of a star's life. That's a very good question.
Excellent, thank you. Well, we've got some great ones coming through from Carolyn here. Is our galaxy a spiral because of the rotating force of the black hole over time?
Yeah, that's a very good question. And I don't think anybody yet knows. The different shapes that we get with, like our galaxy, we think has two arms or two spirals spiraling out. And the different ones that are those football shaped or elliptical galaxy shapes, they all have, or all seem to have, black holes at their very core, but they all rotate. So they're all spinning. The exact cause of why some take on that shape of the spiral arms and some don't is still not yet fully understood. So that's an excellent question.
And that's why science is so fun, isn't it? There's still so many answers to so many questions out there. And if you've got some of these amazing questions, then doing research and finding out more is a great way to get involved. And you never know where that research will take you. Well, we have
Absolutely.
another question here linked to about the stars dying and the dust and the gas. So, does this mean that we will discover new planets and not just exoplanets the more that we're looking?
Or very possibly, because certainly exoplanets, which are planets around other stars, we're finding more and more of those as our bigger and better telescopes find more fainter objects. But also, we're finding within our own solar system, we're now being able to see smaller and smaller chunks of rock or asteroids that are orbiting around our own sun. And
Mm.
some of those potentially still could be relatively large that may be able to be counted as like a small planet. So there's certainly lots of other little bodies or rocky asteroids in our solar system that we don't even know how many there are yet. But I
Excellent.
think, yeah, they're going to find many more.
Yeah, well, they're still finding more moons of our planets and our
Yeah,
furthest reaches as well. So we think, all the moons are counted, but they're not. Samuel has a question. Is our galaxy the only one with planets? I think you've pretty much answered that as well, haven't you?
it's probably not. Yeah, because every star in our own galaxy, as we start to look at most of the nearby ones, they all appear to have their own planets. And every other galaxy that we can then see in these photographs that these incredible telescopes take, they've also got billions and billions of stars. And most likely, around every one of those stars, there are some planets as well.
Excellent. From Victoria, why did only small animals survive the mass extinction?
Ah, yeah, very good question. If you think about that extinction event, the impact that wiped out the dinosaurs, it put all this dust high up into the atmosphere that starts to filter out sunlight. And so plants began to struggle. So there's very little food available at the bottom of the food chain. So it turns out to survive that event, you had to be an animal that was relatively small in size so that you didn't need too much food and you could get by. So I think they've estimated around a body mass of an animal up to maybe 4 to 5 kilograms at most, typically was what could survive that extinction event.
Wow. We've got Karen from the Central Queensland. How do scientists or First Nations decide on the name of a constellation?
Yeah, that's a very good question. Now, typically, most of the constellations that we know them and we talk about, like the Cross or Carina and Orion and so forth, they're usually named from Greek cultures coming into, our Western science. However, one of the stars, I can point this one out in the Cross or the Crux. One of the stars has recently been named with one of Australia's indigenous names. So this little star here, so we've got the four main stars of the cross. The fifth one there is in fact called Jinan, Ginan, from the indigenous people of the Northern Territory, I believe. And so different cultures, of course, everybody has a different name for different stars around the world. But in English, Western cultures, we typically use whatever name came first and then follow that, yeah, for the rest of everybody else in schools and textbooks and so on.
Excellent. Now, we are almost out of time. So, Grant, you're happy to stay and answer some more questions. I'm certainly happy to hear some more.
Yep, sure. Yes, absolutely.
Excellent. So if anyone does need to head off, please, that's fine. We will share the recording with you. But for those of you that have questions in the list or want to hear more, please stick with us. So we've got Charlie here. How large is the black hole in our galaxy, and why is there one in every galaxy?
Oh, that's a very good question. The size, that I don't know. It is certainly extremely the most massive black hole in our galaxy is at the very center. Now, the reason that scientists believe there have to be black holes in our galaxy and in almost every galaxy is to do with the way that gravity works. So if you imagine we've got, say, our solar system, we've got the sun at the middle, and we've got a little planet like planet Earth orbiting around the outside of our sun. It's gravity from the sun that keeps Earth in its orbit. And the further away you get from the sun, all the way out to what used to be one of my favorite planets called Pluto, they move very, very slowly because they're so far away from the sun. If they move too fast, they'd just head off into space and they'd be lost, no longer part of our solar system. So when they look at the gravity, typically planets near the very center orbit very, very quickly. Like Earth takes 365 days to call 1 year, whereas Mercury, right near the sun, the closest planet, goes around once every 88 days. And that means we should see that same pattern for gravity near, well, any large object. So when they look at the distribution of matter in our galaxy from the very core all the way out to the edges of the spiral arm, it turns out instead of the stars near the middle orbiting very, 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 very quickly, and the stars and solar systems way out at the edge orbiting very, 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 very slowly, they all seem to orbit at a very similar rate. It's almost like as if somehow from the core of the galaxy to the very outside edges, it was almost all connected in this kind of solid way. And that
Wow.
means there has to be more mass in our galaxy than we can see. And that's why they believe there has to be something called a black hole. It's got a lot of mass, but we can't see it in
Mm.
with our own
Well,
eyes.
what would happen? This is from oh, sorry, from Chloe. What would happen if one black hole met another? Is
Ah,
it
excellent
possible?
question. And it is possible it has happened, I believe. And they have measured that with one of the first, it's a telescope, basically an interferometer that can measure gravitational waves predicted by Einstein way back in the 1920s or thereabouts. And so these black holes, these large objects coming from dead stars that have gone supernova, they've literally started to spiral in round and round each other and then collide. And they've measured that with these gravitational wave signals, which is absolutely incredible.
Excellent. Now, I think this is linked to the explosion of that star. We've got Xavier. Will we be impacted by that explosion?
Ah, I guess it depends on how close something was to that star when it exploded. Now, for example, our solar system, Earth, we've got really heavy elements on planet Earth, like lead and gold and silver and all these heavy metals. Now, to get these heavier elements on our planet, our sun or our own star hasn't made those. So there's previous generations of stars before our own sun that have lived out their lives, produced all these heavy elements in the core of the sun at this high pressure and density, and then they go supernova, collapse and explode and throw all of that heavy material out into the space around them. And some of that managed to get stuck in our solar system, orbiting our sun, that makes up the elements that make us. Even carbon had to be made in another star. And the carbon that's like inside us, calcium inside our bones, all came from other stars.
Wow. Well, for this is from Joseph. Will the universe end at some point?
Oh, that's a very deep question. And really, we don't know. So, if you think of the model of the Big Bang, it started with this explosion and everything's expanding further and further apart. Theoretically, you would imagine, well, does that expansion ever stop? And we simply don't know in terms of the amount of mass in the universe, whether there's enough to stop that expansion and then gravity can take over again and it starts to re-collapse and basically come back to what they'd call a big crunch. Or maybe it just expands ever so slightly, slowing down, and then it stops. But right now, it's a real mystery because the universe is currently increasing how quickly it's expanding, which is very strange. And astronomers don't know why that is yet.
Some great questions that we still need answered by science. Um, so this is sort of linked to that, especially if we're talking about expanding or things getting closer. So what would happen if our sun moves closer to outside the galaxy or to the Earth?
Well, if the sun were to become closer to us, then it would make a few differences. Because the sun's closer, our year would have to be shorter. So we would now have to go around the sun in, say, 300 days instead of 365 if the sun got closer, because of that gravity. We'd have to be traveling faster, not to collapse and end up spiraling in towards and burning up in our own sun. But on a second, you're kind of hinting there, I think, at how the sun even goes around the Milky Way or the galaxy. It takes, say, if this is the edge of the Milky Way up here, and this is my palm, is the very core of the Milky Way galaxy, to do one complete orbit of the sun going right around to come back to the same side of the galaxy again, takes around 250 million years. So right now, if this is the middle of the galaxy and Earth is over here, our solar system's here with our sun, 250 million years ago is the last time we were on this side of the Milky Way galaxy, which is when that great dying happened, the end Permian extinction event, and 95% of life on Earth completely disappeared.
Wow. We're going to jump back a little bit to some of our animal side of it as well. So, what was the first actual animal to live on Earth?
Oh, that I don't know. The, the first single-celled life was a bacteria, a type of bacteria that made those stromatolites you can find in Western Australia. But then the first complex or multicellular life, so instead of having a single cell, we've got all these different cells working together to make one larger organism. That was around 630 million years ago. Something called the Ediacaran, which is located down in the Flinders Ranges of South Australia. And that early beginnings of complex life, like these little organisms had a structure that looked like a head and a bit of a tail behind them. And that early Ediacaran life, yeah, it's around 630 million years ago. I know the name of one of them. You could look up something called Sprigina,
I can
Spriginina.
send a link with our
Yeah.
follow-up notes to that. Excellent. So that also links to how did the first bacteria form? This is from Victoria.
Ah. The first bacteria, we still don't know. So bacteria needs like a little protective cell, like a cell wall to hold its little bits and pieces inside to keep all the chemistry going that make the cell work. Now, how that happened is still a complete mystery. But what we find is that most of the ingredients, the chemicals, the simple things like proteins and those building blocks for life, they tend to come into Earth almost every day on pieces of rock called asteroids, or once they're on the ground, they're meteorites. And all those little complex molecules, they seem to have been able to develop part of their structure somewhere else. And then it's when they arrive on Earth and maybe water is required to have like a nice ocean, some warm water to help that process. And then these cells somehow formed, but we still don't know exactly how that happened.
Thank you. I'm just going to scroll down a little bit. We've got quite a few questions still to go. Here we go. What is from KC? What is the brightest star visible in Australia?
The brightest star in the sky, in fact, is called Sirius, and that is one, that star is about 200 million years old. Now, at the moment, it's not visible in our night sky. It's already set once it gets dark after sunset. But Sirius, it's the brightest star in the night sky. So whether you're in the northern hemisphere or southern hemisphere, you can still see that one. And it's so old that the dinosaurs would have been able to see that point of light, that star, appear in the sky 200 million years ago, which is really incredible to think about.
Great. Now we've got another couple linking to evolution and extinction. So we've got one here, I think it's from Felicia. Did birds evolved from dinosaurs? And from Finlay, did crocodiles survive the mass extinction that killed the dinosaurs?
Yes, and yes is the simple answer. So, yeah, crocodiles, they were around even before the dinosaurs. They were some of the most earliest forms of reptilians beginning to appear. And yes, they certainly survived that dinosaur extinction event, perhaps being some water creatures on the smaller side. Some of them were able to survive to then later on become the modern crocodiles that we know today. And in terms of birds, yes, those dinosaurs really, birds are modern dinosaurs in some sense because they evolved from some of, yeah, the earlier dinosaurs. But most likely they were some of the smaller dinosaurs at the time. Whether or not they were already able to fly at the time, some of them probably could before that extinction event, but definitely those early birds that have descended from some of those dinosaurs, if they had a small enough body mass, yeah, they were typically able to survive that extinction event.
Wow, we still have so many questions to go, but I think we're gonna wrap up very shortly. Um, and oh, where do we finish? Ooh, there's so many good ones still to go, and I will try to type some answers in for some of these as well. But I think we'll finish off with this one from Xavier. How did you go about learning so much about space, and did you learn it from a young age? And I'm just going to add something in there as well. The things that you're interested and passionate about today really can lead you in to your lifelong journey. I love all these sessions because I still love dinosaurs and I still collect rocks. I've been collecting rocks since I was 4 years old, and I actually ended up working at a museum and getting to play in the geology department. So that's
Yeah.
something that I loved from when I was really little. So these things that you're interested in now, they can be something that you pursue your entire life. I'll hand over to Grant here.
Yeah, absolutely. Yes. And exactly like Karen's saying, the for me, yeah, astronomy was something that I got into when I was about 6 years old. And the reason was my parents borrowed a telescope off somebody and they showed us kids, me and my brother and sister, and we had a look through the telescope. And I still remember seeing the rings around Saturn, that planet Saturn is just absolutely incredible. And that got me hooked. And I was literally interested in astronomy. I used to read books all the way through school. I still read books about astronomy. It literally got me on that pathway. And it's that kind of thing that your passion gets you onto your future pathways because eventually you find it so interesting, you want to learn more. And there's still, as we've just learned, all these unanswered questions about astronomy that we still don't know the answers to yet. So one day, hopefully, some of you might be able to answer those questions in the very near future.
Absolutely. Now, I'm going to send lots of great links as well about the solar system, about some of these fossils we were talking about, these mass extinctions, links to the Australian Age of Dinosaurs as well, so you can continue your research. And yeah, thank you so much for all of your amazing questions. But we do need to finish off now. Please join us again this afternoon if you're not already registered for the Do Dinosaurs Do Maths session at 2 o'clock with Grant. And at 1 o'clock, we've got some trivia based around earth science as well. So there might be some of the things that you've learnt this morning that will help you answer those questions at 1 o'clock as well. So thank you all very much. And a huge thank you to you, Grant, for joining us today and for reading that incredible story that covers some really, really big topics, but really makes it very accessible for, I think, both adults and children. So thank you very much, Grant. And I look forward to catching up with so many of you later on today as well. So bye, everyone.
Thank you. Bye.